Today we're going to learn how to draw electron dot diagrams or Lewis structures for both ionic and covalent compounds. First, we're going to start with ionic bonds. So the way we distinguish ionic bonds from covalent bonds is in ionic bonds, electrons are taken. So in your notes, you need to write it down. Electrons are taken or stolen. And so we use these electron dot diagrams or Lewis structures to diagram what's happening with electrons while these atoms bond. So we're going to draw a Lewis structure for potassium oxide. So the first thing we have to do is just write out the chemical formula for potassium oxide. And if it's going to form an ionic bond, then it's ionic formula. So we have to look at the charges. So potassium is K with a +1 charge. Oxide is O with a -2 charge. And then remember, we use our crisscross rule. So the formula for potassium oxide is K2O. So that means there's 2 potassium atoms and 1 oxygen atom. So when I draw Lewis structures, typically I call it the odd guy out in the middle. So since there's only 1 oxygen, I'm going to put oxygen in the middle, put potassiums on the outside. And then potassium has 1 valence electron, and oxygen has 6. So I'm going to draw the dots. And so in an ionic bond, electrons are taken. And so everyone wants to have a filled valence shell. So oxygen has 6. And it wants 8. So is it easier for oxygen to gain 2 or to lose 6? Good. So hopefully you decided it's easier to gain 2. And then potassium has 1 valence electron. Again, it wants 7. So is it easier to gain 7 or lose 1? And again, it's easier to lose. So what happens is oxygen is going to steal the electrons from potassium. So then potassium, it lost an electron, so it has a plus charge. Oxygen now has gained 2 electrons, so it has a -2 charge. And then the second potassium lost, and it has a plus charge. So when we draw Lewis structures for ionic compounds, I draw the 2-step process. So the first step is you show the original valence electrons, and arrows show where the electrons are going to move to. And then the second step shows that they've now been lost. So potassium doesn't have any, and now they have the plus charges. And then oxygen has 8 now and has a -2 charge. And then finally, what actually holds this bond together is the attraction of these positive and negative charges. So when we draw these Lewis structures, we have to know the number of valence electrons the elements have. So if you don't have these memorized, we're going to label a periodic table. And you just need to write these down. So elements in the first column have 1 valence electron. Second column has 2 valence electrons. Then we're going to jump to boron's column, which has 3 valence electrons. Carbon's column has 4. Nitrogen's column has 5. Oxygen's column has 6. Fluorine's column has 7. And then helium's column has 8. So write these down if you don't know them. However, you do need to get to the point where you have these memorized. Okay, so you just need to be able to look at these 8 columns on the periodic table and know how many valence electrons elements have if they're in one of these columns. So now we're going to switch gears to covalent bonds. And we're going to start with just a single covalent bond. And so covalent bonds form when a pair of electrons is shared between 2 atoms. So in your notes, make sure you get down our definition of a covalent bond. And again, if you see I've underlined shared, so you can like highlight, star, underline, shared. So how we're going to differentiate between ionic and covalent bonds is in an ionic bond, an electron is taken, and in a covalent bond, electrons are shared. And so typically we see covalent bonds between 2 nonmetals. And my example is hydrogen. So hydrogen is naturally found in the diatomic state, so it's H2. So one hydrogen bonded to another hydrogen. So hydrogen has one valence electron. And hydrogen and helium are special. They only want 2 total valence electrons. So these 2 hydrogen atoms move close to each other and pair up so they can share both their electrons. So now they both have 2 valence electrons. And so when covalent bonds form, they can form in single bonds, like we saw in the previous slide, or electrons can pair up with more than one pair. So double bonds can form. So a double bond is 2 shared pairs. And then triple bonds also form, which is 3 shared pairs. And just make sure we know that a pair is going to be 2 electrons. And so down below is how we diagram. So for a single bond, as most of the time you'll see a dash. So just one line is showing a single bond. Or if you want to visualize the electrons, it could be 2 dots. A double bond is diagrammed with 2 dashed lines. Or you can diagram with 4 dots to show it's 2 pairs of electrons. And then a triple bond can be diagrammed with 3 dashed lines, or it's going to be 3 pairs of electrons, so 6 sets of dots. Either way is fine when diagram. I typically draw the dashed lines just because I feel like it's quicker. So when we draw electron dot diagrams or Lewis dot diagrams, we're going to follow these steps. So first we're going to count all of the valence electrons, and then we're going to draw atoms and start placing electrons around each atom to fulfill the octet rule until you run out of electrons. So when we draw atoms, how do we know which one goes in the center? Okay, the center atom, I call it's the odd guy out. Okay, or the real rule in chemistry is the least electronegative atom goes in the middle. Okay. However, if you forget the trend for electronegativity, it's the odd guy out. And then let's review the octet rule. Okay. So for the octet rule, hydrogen and helium want 2 electrons, and then all others want 8 electrons. All right, so now we're going to do our first example problem together. So we have carbon tetrachloride, or CCl4. So step 1 is to count all valence electrons. So I'm just going to count based off the column of the periodic table. So carbon has 4, and then chlorine has 7, and then the subscript is telling us there's 4 chlorines. So I'm going to multiply that by 4 because each chlorine has 7 valence electrons. So 7 times 4 is 28, 29, 30, 31, 32. So there's going to be a total of 32 valence electrons in this structure. So now the next step, we're going to draw the atoms, okay? And it's odd guy out. So it's carbon and 4 chlorides. So the single carbon is the odd guy out. And then I'm just going to evenly space the 4 chlorides around it. And each dash is representing a single bond, which holds 2 electrons. Okay. So we started at 32 electrons, and then this contains 2, 2, 2, 2. So if we add it up, it's 2, 4, 6, 8. So by drawing those dashed lines, we've used 8. So now we have 24 valence electrons left. So now when we start filling electrons, our goal is to fulfill the octet rule. So if you see hydrogen or helium, they want 2 electrons, and all others are going to want 8. So I'm just going to start with this chlorine. So it has 2 here, and it wants 8, so it needs 6 more electrons. The way we draw those 6 are a lone pair. Okay. So by lone pair, they're not bonded, so I'm going to draw them as dots. But then they're pairs, so I'm going to keep them grouped in sets of 2. So I use 6 electrons there. So now I'm down to 18. So now I'm just going to move clockwise. So this chlorine has 2, and it wants 8. So I'm going to draw 6 more. So now I'm down to 12 electrons. I'm going to move on to this chlorine. Again, it has 2, and it wants 8. So I'm going to draw 6 more. And then my final chlorine, again, has 2, one's 8, so this one also needs 6. So I've used up all of my valence electrons, and then now I'm going to check carbon. Carbon has 2, 4, 6, 8. So all 5 atoms in my drawing have all fulfilled the octet rule, and I've used all 32 electrons. So this is how I know I'm finished and how I've drawn a correct Lewis structure. On this slide, we're going to draw 3 more Lewis structures together. So our first one is water. So we're going to start with the formula. Water is H2O. So for valence electrons, hydrogen has 1, but there's 2 of them. I get that from here. So 1 times 2 plus oxygen, which has 6, so a total of 8. So now we're going to place the atoms in the middle. Oxygen in the middle, hydrogen's on the outside. So we've started with 8. We used 2 and 2 here, so a total of 4. So we have 4 more electrons left to draw. So now we go through and satisfy the octet rule. Hydrogen only wants 2, and it has 2 in each bond, so both hydrogens have been satisfied. So now we look at oxygen. It has 2 here and 2 here, so 4 total, and it wants to get to 8. So I need to draw 4 more electrons, and the way I draw those is 2 sets of lone pairs. So we're finished with water. We have used all 8 electrons, and each atom has fulfilled the octet rule. All right, so now let's jump down to ammonia. Ammonia is NH3. So if we look at the periodic table, ammonia has 5 valence electrons, hydrogen has 1, and there's 3 hydrogens. So again, 8 total. The odd guy out is N, so then I'm just going to draw 3 hydrogens, kind of evenly spread out. So I started with 8, and I've used 2, 4, 6. So I only have 2 valence electrons left. Hydrogen only wants 2, so each hydrogen is satisfied, and then nitrogen has used 2, 4, 6, and it wants 2 more. So that final 2 I'm going to draw as a lone pair. So this is our structure for ammonia. And then last, we have methane. Methane is CH4. So carbon is 4 valence electrons, hydrogen has 1, and there's 4 of them. So again, a total of 8. The odd atom out goes in the middle, so carbon in the middle. Hydrogen surround it. And now we're going to count electrons. So we started with 8, and we've used 2, 4, 6, 8. We have used all 8 valence electrons, so there are none left. And then we're just going to make sure every atom has fulfilled the octet rule. So hydrogen has their 2, so hydrogens are happy, and carbon has 2, 4, 6, 8. So carbon is happy.